Okay, thank you, Nick. It's a real pleasure to be here. Thank you, everyone. So I actually want to thank Misha because he, I think, helped set up my talk really well. As he highlighted, we have a lot of tools. We have pretty complex problems. And at this point, we actually have large teams of people behind these problems. So what I'll talk about is how to really manage these projects and how to set up a team of data scientists and machine learning experts that is successful. So in terms of the agenda, I'll talk about actually putting the team together, selecting and framing the problem, and what are some of the considerations that are often missed when you're really choosing what problem to focus on, how to break down the problem, and how to solve the problem, and how you should evaluate the solutions to make sure that the solutions are driving impact. So building a team. Well, it might seem simple. I'll actually even use the same domain. So my team is the machine learning team at Facebook that's focusing specifically on advertising. So when you're trying to solve an advertising problem, you're trying to select a set of ads, in our case to show in your feed, that are going to be relevant, that are going to bring good ROI to the advertiser, as well as deliver money and revenue to the company. So this is a typical real-world problem, and at the surface, it might seem easy to solve. All you have to do is take a set of ads and select which ads to display. However, underneath, there is layers of complexity. So at Facebook specifically, we have over 1 billion ads, and at this point, we have over 1 billion people. So thank you for joining. Keep joining. That'll make the problem even harder and more challenging to solve. So even just selecting the set of ads that might be relevant to somebody is a pretty challenging information retrieval problem. You have some advertisers that have very broad targeting. They only select the specific gender or specific age group. There is other advertisers that are targeting the skier who makes over 100K a year, lives in Seattle in the Capitol Hill neighborhood, and goes on skiing trips only to Whistler. So figuring out how to select those ads requires deep expertise in information retrieval. At the same time, once you select the ads, you usually end up with still trying to have a large set of ads that you need to display and optimize for revenue for the publisher as well as the ROI for the advertiser. So advertisers have different objective functions. Some advertisers want to drive clicks to their website. Other advertisers actually want to sell something. So in order to do that, we need to build models that predict these marketing objectives. If I display an ad to you, are you going to click on this ad? If I display the ad in a specific order, is that going to change things? And how much should you actually charge for the ad? So that requires people with machine learning skills that will build those models. And once we have those models, we still have to test them. So in order to test them, the most common way to do that is you will run A/B tests, and you will actually try to detect changes. I will later show that that actually requires deep statistics background in order to really interpret these tests and make the right decision. Finally, since these are large systems, I'm still hearing that over time we'll have the perfect tools and we will not need any engineers to actually solve those problems. My observation right now is that even the companies that provide these machine learning systems that hopefully solve most problems still use a lot of engineers within their company as part of the machine learning group. So when you're building such a group, you actually want a diverse set of skill sets, and you want experts in the specific set of skills. The other question that often comes up is domain expertise. So domain expertise is very useful, but what I have found a little bit surprising to me is it's not actually as critical in the data science area. The one place where you really need the domain expertise is in your engineers. So engineers is, with engineering, you see people where past performance is always indicative of future performance. With experimentation and research, there is a lot more variability, but engineering is the area where you want to ensure that you have your domain expertise and have people that understand how to put the system together to enable the modeling and to enable the scale that's needed to solve the problem. So when you're actually hiring these people, you often look for tons of resumes. So I always see tons of resumes from academia, and the question comes up, should you hire from academia or should you hire people with industry experience? There is a lot of value that comes with industry experience, and this is around the domain focus and really shortcutting the learning experience. People from academia usually fall into two groups. People with huge amount of experience that for most companies it might be almost a waste to hire them because they would need a large position, and people who are new graduates who will take a lot of time to train. So large companies actually do hire a lot of people from academia, and most of them are the new graduates because the large companies can afford to go through the training cycle. But if you're a startup, then you might want to consider having some people with industry experience. The last thing that I want to touch on when building a team is what areas should you invest on versus kind of outsource or find other sources. So as I already mentioned, we're seeing a lot of tools and we're seeing a lot of research happening in academia. So the area that you probably should leverage existing systems from is the tools for the science and the knowledge from academia. So when you're building a team, your focus should actually be around investing in the domain and having the people that know the specific techniques that work for your domain versus people who are developing new techniques. Okay, so now let's assume we already have the dream team. We've hired all the right people. So what happens next? We need to select somebody to lead this team. The most common thing that happens is we take all the people that we've hired. We've obviously hired all the best experts. We figure out who is the most senior person, and we put that person as the lead. And that's very tempting to do and kind of very natural, and it almost always fails. So the most senior person will most frequently be, let's say, the most established researcher, or maybe an engineer with a huge number of years of experience. The most commonly is the most senior researcher. And what happens is that person focuses on their research. They don't actually care necessarily about the domain. They want to further the research. They don't know what matters for the people that are on the team in terms of management. So over time, those teams either are miserable, people leave the team, or the teams exist and don't deliver impact for the product. So what I've observed is what you actually need is somebody with baseline experience in all of these. So somebody who understands the domains and actually has done some work in each of these, and maybe they could actually even build the whole system from scratch. They would not build the best system, and that's why you need the experts on the team, but they understand the different techniques, they understand the challenges in engineering, and they actually understand the challenges around motivating people. Okay, now we have the team and the lead. So where do we actually put that team? So this applies even to startups, even in I was in a startup at Medio, and you think with 20 people or so, you don't have to worry about where you put the science team. Well, actually, in reality, what happens is there is a set of different approaches. There is the centralized research team like MSR. There is applied research teams. At Facebook, we have the data science team. That's a centralized applied research team. There is different models of embedding researchers. At Microsoft, there was live labs where researchers would actually go and sit with a specific team and be funded by a specific product team. You can also form the team and just embed the team either in engineering or in a business division. The most tempting thing here that people tend to do is try to embed a researcher. This is a small investment. It seems like it would work very well. You have one dedicated person that knows the machine learning. You put them with a product team. It has to work. Well, it doesn't. So you really, the centralized approach is critical. And you can go either way. You could have a large centralized team of researchers like Microsoft Research, or you can have a team that's a dedicated team of machine learning experts that's sitting specifically in a product team. But from my observation is like the most tempting thing of embedding a single researcher in a product team just doesn't work. So as I already mentioned, it's really important to make sure to know how to motivate this team. So if you have a team of researchers, the standard approaches of if-then that are used in industry, if you build the best model, I'm going to pay you a big bonus, those actually don't work. And this area has a very deep amount of research and work that has been done in it. Most people are not even aware about it, and most people and most companies actually ignore it. So there is a really good book by Pink that I would encourage you to read, Drive, that talks about what motivates people that do creative work. So in order to build a machine learning system and solve some of these complex problems, you're doing creative work and you're solving intellectual challenges. So there is really three aspects that are important. You need to ensure that people on the team have the autonomy to make the decisions. You need to ensure that they focus on mastery, so they have opportunity to learn, and they actually have the opportunity to show their expertise in a specific area, and that they have a purpose. So creative people ultimately want to solve a problem that matters and understand why this problem matters and why it is important to solve. Really what you want to focus on is autonomy, purpose, and mastery. Now we have a team, and that team is hopefully motivated, has a good leader, it's working successfully. So what are some other things to watch out for when you're selecting and framing a problem? So as you can see here, what we commonly see is we have this awesome data on X, and we've cleaned it up. We've came up with this super technique for solving the problem that's really complex, and the data and the patterns are looking very fascinating. Great, this sounds wonderful. What are you going to do with it? And that's where the question often stops. So people focus on finding the right approaches, and people focus on finding patterns in data, and a common criticism is that's where the impact of some of these teams stops. So the question is, how do you ensure that if you're the leader of such a team, how do you ensure that you're selecting and framing the problem correctly? So this is actually a pretty simple flowchart that I found to work pretty well. I don't think there is anything surprising here. There is a set of steps that you follow. But what I've observed is that often people forget some of these steps, and sometimes we see inversions in these steps. And some inversions might actually be reasonable. Sometimes, for example, the problem is simple enough that you don't have to break it down. In advertising, that's definitely not the case. You have a pretty complex problem. I already mentioned you want to break it down into information retrieval. You want a modeling stage where you're predicting specific events. You have an auction where you're actually pricing the ads. And each of these should be solved as a separate problem. And then you can actually create a pipeline that delivers the final results. Another step that I'm sure everyone here will say they've never done it, and I consistently see happening, is building the model before you select your objective function. So very often we see people building models, and especially in companies where you have an A/B testing framework, throwing that model in production and saying, look, I see good results. I see X increase or I see Y increase. This is really, that's where kind of your statistician comes in, hopefully, and says, this doesn't work. You really need to set your objective function. You really need to know what you're measuring and what you're optimizing, because the data in industry is so complex and so changing that you will always find some positive results for almost any algorithm that you throw at any data with any set of features. So I definitely want to caution you to follow those set of steps, and if you're skipping any of them, have a good reason why you're skipping it. Another step that's sometimes forgotten is thinking about the scale. So is the system going to respond the same way when you scale it as it's responding in your prototype? So sometimes people will build initial prototype in R, and they will use 1 day of data, and they will assume that this works well. And then what you find out is, well, oh, I forgot that there is a weekday and weekend effect. Oh, I forgot that the specific day I chose happens to be a holiday, and that data is not actually representative. So it's important to think about all of these aspects when you're selecting and framing the problem. And the other thing I want to highlight is this flowchart might also look like the steps you take to actually solve the problem. And that's true. You really want to take all of those steps when you're really selecting and framing the problem. And the only missing ingredient is building the model. And that's why we can now simply move to solving the problem approach. Since the same steps already apply, the only new steps you need to add is the modeling and feature selection. And those are usually not forgotten, so that's not surprising here. But there is other considerations that I have observed are often really either forgotten or dismissed. So some things to keep in mind is you want to establish a baseline, you want to check your assumptions. The assumptions are very, very important. So for example, in online advertising, one big assumption that tends to be dismissed is let's say for click prediction, we are assuming that there is a baseline probability with which either users are clicking or a specific ad is being clicked. And that's not actually a true assumption. We're also often assuming that advertisers are truth-telling, which would be a good assumption if advertisers knew what they're telling the truth about. So that becomes pretty hard to ensure that is the case. And once you understand those assumptions, you can actually adjust. So for example, since we don't actually have an inherent probability of click for a user, that's why we use online models, that's why we use continuously changing counts, that's why we add a large set of features to ensure that we try to understand all the dimensions in which the data is actually varying. Okay, so we have the problem, we've solved the problem. How do we now evaluate the solution? So I already mentioned that metrics are very important. And to illustrate how complex they are, if you ask somebody, well, how do you measure a good advertising system? Most people will say, well, isn't that trivial? You just want more revenue. Well, it sounds trivial. However, how do you get more revenue? Well, I ran an A/B test and actually see that I'm getting more revenue from my ads. Well, that might work if you were trying to find a system that works great in a single instance. This is a system that's running in production. This is a system that is bringing actual revenue to the company, but it's also a system that has a lot of agents acting on it. So you have people that are unpredictable. They might like a specific brand today, and suddenly they go and finally buy the product, try it, and hate the product, and they no longer like that brand. They might click on a lot of ads when they're at home, they go to work, and suddenly they're professional and they no longer browse ads and buy things while they're at work. So there is a lot of variability around the agents, and the agents actually have different objectives. As a user, what I want to do is I want to read my content, maybe I want to buy something that's of interest to me, but usually I don't want to see a huge number of ads. As a publisher, what I want to do is I want to make money. As an advertiser, I want to pay as little as possible, but actually get a good ROI on my investment and deliver, basically get impact from the ad that I'm displaying. So in order to optimize the system, what you really need to do is you need to define an objective function that tries to find an equilibrium and actually tries to optimize for the objectives of all of those participants. So the metric might seem very simple on the surface, but it is actually a very complex metric. In terms of online and offline, so again, you often hear pitches that online is the only way to test because, for example, in advertising, you need to see if users actually react. Well, however, this is a system that's in production. This is the system that's driving all the revenue. If you want to test something that is going to decrease the revenue by 40% potentially, you probably don't want to check that in production. So there is a lot of value in actually having both offline and online evaluation systems. Unfortunately, what you find out is that you probably need different metrics for both. Because in the online system, you do have the actual actions of people. In the offline system, you don't. So, for example, you might need an offline system where you're optimizing for log loss and an online system where you're optimizing for this combined function. So some practical lessons on experimentation. So there is few things that are important to consider that a lot of people forget, and this is kind of a checklist. If you don't have that statistician, at least think about these things when you're setting up online experimentation. So it's important to think, how do you split your traffic? Common ways of splitting by, well, most common one by request might work for some cases. Recently, a lot of people have been switching to user-based splitting, but even that doesn't always work. For example, in advertising, you have budget considerations. So if you split by user, you might have an algorithm that is cannibalizing from the potential budget of your control, and your results might not actually be representative. It's important to consider how long you should be running the test. So the standard statistical significance and power are usually taken into account, but something that's often forgotten is seasonality effects and novelty. So what you want to do is you want to ensure that all of these are considered when you're running the test and when you're evaluating the data. Couple of other things that are also often ignored is model interactions. And there are two types of model interactions. There is from running multiple models at the same time. There is always the question of if you use a model, what data set do you use to train your model? Do you partition the data and ensure that you're using only the data from the model that was in the B test? then you actually run into data sparsity. If you're using all the data to train your models, now models are benefiting, the model you're testing is benefiting from the other model that's running in the control. There are similar problems with previous experiments. So even if you sequence the data, the experiments, what happens is there's residual effects from the model. So you've actually made a change and people have gotten used to that change. So testing a new model might not be representative until some of those effects decay. So to summarize, I actually want to leave you with one insight. I've heard a lot of discussions around failure and failure being valuable. So failure can be valuable, and you should actually plan for valuable failure, but that requires planning. So at Facebook, we have a saying that fail, but fail convincingly. So ensure that you've actually tried all of the avenues, and instead of just saying this didn't work, which brings no information, does that mean that if somebody else tries it, it also won't work? Does that mean that if you change something, it also don't work? If you actually are treating failure as a useful result, ensure that it actually is useful and it brings some additional information. There are some other considerations that I won't have time to go over, but I would like to encourage you to catch me during coffee break and lunch, and we can talk about all of the other considerations that ensure that the impact is actually delivered and the project is successful in production and in industry. Thank you.